All right, everyone, in this video we're going to be talking about something called Pythagorean trigonometric identities. So we are leaving graphing behind, for a while here. We are going to still be talking about trig functions, however. And particularly in this section, we're going to develop an equation using the unit circle. And then I'm going to show you a couple of different ways to represent that equation. And then we're basically going to be simplifying some expression with trig functions. We're going to try to simplify them down to a single trigonometric function. So we're going to be doing something like this. We're given tangent squared x plus 1, and we're supposed to simplify that to a single trig function. Another example here, 1 minus sine squared, simplify that to a single trig function. Secant squared x minus tan squared x, simplify that to a single trig function. So that's what we're going to be doing. But before we do that, we need to develop some equations here. So actually I want to start with this Pythagorean part of it. So Pythagorean obviously comes from the Pythagorean theorem, which, given a right triangle, states that a squared plus b squared equals c squared, right? All right, now if we were to sort of translate this to the unit circle, the a squared plus b squared equals c squared part, let's say I got my triangle right here. And this is sort of my a, which represents the x direction, my b, which represents the y direction, and then my c, okay, see there I got a right triangle. So the a, like I said, represents the x direction, right? So a sort of is my x, b is my y. Now my c, this is the unit circle. The unit circle by definition has a radius of 1, right? So c is actually just 1. So I could actually take this idea and translate it back to this other equation here. A we said was x, so x squared. B was y squared equals actually just, 1 squared. Okay, and further, if you remember from the unit circle, we called the x coordinates, remember that was cosine x, and the y coordinates were the sine x, or sine, should we say sine theta would be better, sine theta. All right, so the x coordinate again represents the cosine, and the y coordinate represents the sine. Okay, so I could further substitute here. My x represents my cosine, so it's actually cosine, and since it's x squared, it's going to be cosine squared theta plus sine squared theta equals, 1 squared is just 1. And this is the most important equation. This is our Pythagorean identity. Cosine squared plus sine squared, and could also be rewritten sine squared plus cosine squared. That's actually probably how you'll see it written more often. Sine squared plus cosine squared equals 1. Either way, it doesn't matter, just change them around. So this is the main trig identity here. The other two that we're going to develop just come from this. Right? So the next one, you don't need to know how to do what I'm going to show you, just it's just to kind of prove to you how do we get there where we get there. So what I'm going to do in this one is I'm just going to divide everything in this equation by cosine squared. Okay. So if I'm going to divide by cosine squared, I have to do it to every single function in this equation. All right. So cosine squared divided by cosine squared is just 1, right? Sine squared over cosine squared. Hopefully you remember what that is. Remember sine over cosine equals the tangent, right? So this is actually just tangent squared theta. And then this other one, 1 over cosine squared, you might also remember that secant is the inverse of cosine. So secant is 1 over cosine. All right, in the same way that cosine was 1 over secant. They're interchangeable in that way, right? So 1 over cosine squared is actually equivalent to secant squared theta. And this is my second important equation here. We can also rearrange this really any way we want to. So we could also write this as, well, tangent squared theta equals secant squared theta minus 1. Okay, if I just subtract the 1 over. So there's different ways that you can rearrange this, but this is my second important equation. In my third important equation, we're going to do the same idea, except take it over here. I'll take it down here. All right. So in this third important equation, I'm going to take this original sine squared plus cosine squared theta equals 1. And this time I'm going to divide everything by sine squared instead of dividing by cosine squared. So divide by sine squared, divide by sine squared, divide by sine squared. And what happens here? Well, sine squared divided by sine squared is 1. Plus cosine divided by sine. That, if you might remember, is actually not tangent, but cotangent. It's the inverse tan, right? Or the inverse of tangent. So, all right, cosine over sine squared is cotangent squared. Okay, equals, and then the 1 over sine. So cosine over sine equals tan, cotan. And then 1 over sine, you might remember, is a ratio we call cosecant. So this is actually cosecant squared theta. And this is my third important equation here. 1 plus cotangent squared equals cosecant squared, which again, we could also rewrite this as cotangent squared theta equals cosecant squared theta minus 1. All right. So there's 3 different equations. Now you can rearrange these any specific way that you want to by just adding, subtracting. We're going to be just basically manipulating these equations, making substitutions to simplify some equations. So make sure you've written these down. You're going to use these to solve our delta math problems here. So let's go ahead and see if we can apply these. So our first question, switch over here. Our first question, we're supposed to simplify this to a single trig function with no denominator. So let's just look at our options. We got a secant squared and a tangent squared. Okay, so let's see how we can make a substitution. It looks like we're definitely going to want to use the second equation, right? So you could really choose either one. Let's just take this one right here. Tangent squared theta equals secant squared theta minus 1. So I'm just going to replace this with secant squared theta minus 1, because that's what it says it equals. So we got secant squared, and they use x, so you can use x or theta interchangeably, it doesn't matter. So secant squared x minus, and then again, we're going to replace tangent squared theta, or tangent squared x, with secant squared. So minus secant squared x minus 1. Right, I just took that from right here. So if you actually wanted to rewrite these using x instead of theta to make it less confusing, that's fine too. All right, so all I did was substitute it, and now you'll see a nice thing that happens here. Well, it's going to become secant squared x minus secant squared x minus 1. Obviously, secant squared minus secant squared does cancel, so it leaves you with, and actually, sorry, this is plus 1 because we distribute the negative symbol. So all we're left with is just 1. 1 is the only thing left. So we got it to a single, in this case, not a trig function, but it's even better. It's just a single number, and that is 1. So we're just going to type in 1. All right, let's go ahead and try another one. So this one looks like we'll probably use the same exact equation. So we're supposed to simplify this. We probably don't want to replace 1. We're going to want to replace that tangent, right? So if we look at tangent squared theta, what could we replace that with? Flip over there, tangent squared theta. We could actually make the same substitution. It's secant squared theta minus 1. So we just go ahead and do that. It might seem like we're adding to it, but it's actually going to be good for us. So this is secant squared x minus 1. Okay, we're substituting that in. Plus 1. Okay, because we still got the plus 1 there. And then you'll notice the minus 1 and the plus 1 are going to cancel. So we're left with just secant squared x. So there, we simplified it. These might seem confusing at first, but I promise once you get the hang of it, it's not bad. And just a note, remember when we actually type in trig functions, instead of doing like secant of x squared, we don't actually write it that way. We write it as secant squared x. So you just hit the little up arrow and put it up there. So just a note there. All right, let's go try another one. Okay, here's going to be our just original Pythagorean identity. This one's actually very easy. Sine squared plus cosine squared, because, I should ring a bell, sine squared plus cosine squared is actually that whole thing just equals 1. So our answer here is just 1. We know that. So that's all we got to type in. So as long as you've got these written out next to you, I promise these aren't too bad. All right, next one, 1 minus sine squared. So we need to find a substitution for sine squared of x. Well, sine squared of x. Now we are just going to need to rewrite these a bit here. So let's just take this equation and I'm just going to rewrite it. All I'm going to do is move that cosine over. So I'm just going to write this as sine squared. I'll write x since we're talking about x's. Equals, and then I'm just going to subtract that over. 1 minus cosine squared x. Right, so I've just solved for sine squared. You could even add that to your list if you want to. In the same way that cosine squared x, if you solve for that, would be just subtracting the sine over. So it would be 1 minus sine squared x. So you can manipulate these in any way necessary. So we want that sine squared, so it's 1 minus cosine squared. I'm going to replace that in. So we're going to replace this. 1 minus cosine squared x. It seems like we're adding to it, but there's going to be things that cancel, which you can see here. It's going to be 1 minus 1, right? So those cancel. And then we do have to distribute that negative in. So minus cosine squared is just, well, cosine squared x. Which again, we could have got from here. Cosine squared x is 1 minus sine squared x. All right, so that's all we're going to type in. It's just cosine squared x. All right, let's see one with a cotangent. So let's just locate one of our cotangent ones. Cotangent squared, let's go ahead and replace that. We can replace it with cosecant squared minus 1. Let's go ahead and do that. Cosecant squared minus 1. So 1 plus cosecant squared minus 1. And you'll see here, obviously, if you distribute that through, it just becomes 1 plus cosecant squared x minus 1. And they cancel, and we're left with just cosecant squared x. So that is what we'll type in. Hopefully these are starting to click for you. They might seem weird, but again, it's just plugging things in. So next one, we're looking for tangent squared x plus 1. Well, we actually can just look here. Tangent squared x plus 1 is the same as secant squared. So that would be all you type in is secant squared. See if there's any different ones. All right, let's try. This is our last one. Secant squared x minus tangent squared x. So just choose one of them to replace. Let's replace secant squared this time. So secant squared is the same as 1 plus tangent squared. So we're going to replace this with 1 plus tangent squared minus tangent squared. You can obviously see tangent squared minus tangent squared cancels, and we're left with just 1. All right, so hopefully you get just familiar with using these. You can see they aren't difficult after you get familiar. If you are still struggling, though, please do reach out to me as always.